Hello everyone, welcome back to my YouTube channel. I am Lochana Amar, studying at Sri Venkateswara College of Engineering, Bangalore. I am from the Department of Information Science and Engineering. Currently, I am studying in 4th SEM. In this video, I am going to explain about the subject Discrete Mathematical Structures. Subject code is BCS5A. Topic of today's subject is Rook polynomials in mathematics. First, let us see about the introduction. Introduction to Rook polynomial. Rook polynomials are the class of polynomial function associated with combinational problems on chessboards. They count the number of ways to place non-attacking rooks on the chessboard or similar grid. The study of Rook polynomial is important and applications in algebra and geometry. Definition of Rook polynomial. The Rook polynomial is defined for graph representing a chessboard. The coefficient of x bar k and r of g of x denotes the number of ways to place non-attacking rooks on the board. Non-attacking means that no two rooks share the same row or column on the chessboard. Construction of Rook polynomial. Rook polynomials can be constructed using the principle of inclusion and exclusion. This method accounts for all arrangement while excluding configurations where rook attack each other. The polynomial can also be derived from the determinant of a matrix representing the rook placement. Let us now see the example of rook polynomial. For a 2 times of 2 boards the rook polynomial is r of 2 comma x is equal to 1 plus 2x plus x to the power 2. The polynomial reflects the configuration of placing 0, 1 or 2 rooks on the board. A more complex example is 3 times 3 board yielding r of 3 comma x is equal to 1 plus 3x plus 6x square plus 6x cube. Let us see some of the applications of Rook polynomials. Rook polynomials are utilized in enumerative combinations to solve counting problems. They find application in statistical mechanism and network theory, particularly in understanding configurations. Furthermore, Rook polynomial helps in studying the properties of symmetric functions. Relationship to permanent and determinants. The Rook polynomial is closely related to the determinant of a matrix, which counts certain configurations. The determinant can provide insignant into the number of arrangements of non-attacking hooks. This relation depends on the connection between Rook polynomial and linear algebra. Now let us see some of the properties of Rook polynomial. Rook polynomials are symmetric in nature, reflecting the symmetry of the chessboard. They are also multiplicative for disjoint unions of graphs or board. The degree of the polynomial corresponds to the size of the board, showcasing a clear link between size and complexity. Rook theorems. Various theorems such as Rook theorem provide essential insights into the structure of Rook polynomials. These theorems often combinational identities and can simplify calculations. They offer a framework for understanding and identifying combinational principle at play. Let us see some of the advanced topics in Rook polynomials. Advanced studies may explore Rook polynomials in higher dimensions or with additional constraints. Research continues to uncover new relationships between Rook polynomials and other mathematical areas. These studies lead to potential generalization and new application in combinational theory. See, last but not the least, the conclusion. Rook polynomials serve as a powerful tool in the combinational mathematics and continuing theory. Their applications stretch across various fields, making them a significant area of study. Understanding Rook polynomials enhances our grasp of combinational structures and their properties. Thank you for watching my video.